is Matthew Goodlaw, and I work at the New Mexico Public Education Department, and will be presenting you with this afternoon's webinar. I want to thank you in advance for your attendance and for your questions. Your questions in the past few days have been very helpful in helping us to refine this webinar, as well as to understand where we can be more clear. I promise to do my best in this webinar to help you understand the NMTEACH summative form using steps. So we're going to dig into the summative evaluation form and details. Alicia Duran, a teacher in Albuquerque at Volcano Vista High, has been gracious enough to let us use her summative form for this year as an example to walk through. So the form looks much like the prior form, though as you'll see, should be much simpler, more uniform, and easier to understand. So let's take a closer look. So the header of the form is similar to as before, where you have the teacher's name, the steps, and we're going to talk in greater detail about the steps, no longer groups, levels, and tags, the teacher's license number, the overall score, so 175 out of 200, overall summative score, the overall effectiveness level, exemplary in this case, and the school district and high school or school that the teacher was last observed at. That's an important point to recall, that if your teachers teach at multiple sites, it's the site that they were last observed at where the evaluation gets sent. So this is the header of the summative form. Digging into the steps, you can see that there are now 3 steps, and each of the columns represent the various criteria of the evaluation system. So no longer do we have groups, Group A, Group B, Group C, or tags, tag 1 through 13, and levels, elementary, middle, and high school, which formed, a daunting number of combinations of groups, levels, and tags, graduated considerations. We now have steps. Step 1 are for teachers who have no student achievement data in the last 3 years. And in that case, 0% of the teacher's evaluation is associated with student achievement. For a Step 1 teacher, 50% or 100 points of their evaluation are associated with the classroom observation, domains 2 and 3 of the NMTEACH rubric. Step 1 teacher, 40% of their evaluation is associated with planning and preparation and professionalism, or domains 1 and 4 of the NMTEACH rubric. And 10% is associated with teacher attendance and or surveys. If a teacher has both surveys and attendance, it's 5% allocated to attendance and 5% allocated to surveys, or 10 points each. 20 points if you just have attendance or surveys. A Step 2 teacher is a teacher that has 1 or 2 years of student achievement data, and in that case, the 25% of the teacher's evaluation is going to be associated with the student achievement criterion. 40% is going to be associated with the classroom observation, or domains 2 and 3. And 25% will be associated with domains 1 and 4 of the NMTEACH rubric. And similar to the Step 1, 10% will be associated with teacher attendance and or surveys. A Step 3 teacher is a teacher with 3 years of student achievement data. And in that case, 50% of the teacher's overall evaluation will be associated with the student achievement criterion. 25% will be associated with classroom observation, domains 2 and 3, and 15% will be associated with domains 1 and 4 of the NMTEACH rubric. And again, 10% will be associated with teacher attendance and or student surveys. If you have both, 5% will be with surveys and 5% will be with teacher attendance. If you only have one, then 10% will be towards that you have, attendance or surveys. So as you can see, it's a much simpler system to understand. Let's reiterate that a little bit. And step one are teachers who have no student achievement in the last 3 years. Step two are teachers who have 1 to 2 years of student achievement data. And step three are those teachers who have 3 years of student achievement data. And as it says here, they also teach courses related to that STAM. You can find which course codes are associated with which assessments in the course assessment linkage document that is located on the NMTEACH website under the toolbox link under the superintendent's header. It's a spreadsheet that on each of the sheets in the spreadsheet or workbook, Excel, has information about the course codes associated with that assessment. Please take a look. So as you probably are aware, the summative reports will be released in September 2016, and these will include all of the value-added scores associated with an individual teacher from the assessment batteries of DIBELS, EDEL, SBA, PARC, and end-of-course exams. It will include student achievement data for the following 3 school years, 2013-14, 2014-15, and 2015-16. So finally, we're caught up and we're current with respect to the student achievement data. No longer is student achievement lagging 1 year. This should be really beneficial to instructional leaders and teachers who want to look at the teachers' practices and behaviors as it relates to student achievement. Note, district plans no longer exist. If we have student survey data that was submitted, it will be used as part of the multiple measure. In other words, if at least 10 students or parents responded to the student or parent survey, and it was submitted to the UNM survey engine, and then that was transferred to the PED, we will use that data as part of the multiple measure. If districts didn't select attendance for the 15-16 school year, and the district did not submit attendance to the state, we will not use attendance in the teacher's summative report. If a teacher didn't submit survey data for whatever reason, they will not receive points for surveys, and those points will be prorated into the attendance portion of the survey. Vice versa, if we have surveys but don't have attendance, yes, they will be the attendance will be prorated into the survey portion. So the 5% that would have been attendance is now 10% on surveys, and so on and so forth. So again, this is looking at the scoring portion of the summative form, and as you can see now, student achievement is associated, in this case, a step 3 teacher with 100 points possible, and this teacher earned 87.07 points of those 100 points. This teacher has 50 points possible in domains 2 and 3, or the classroom observation, and earned 44.5 of those points. This teacher earned 29 of the 30 points possible on domains 1 and 4 of the NMTEACH rubric, earned 14.85 points of the attendance scores, and overall earned a score of 175 out of 200. Below that, that scoring portion of the summative report, you're going to see the cut scores that are applied to the summative overall score. A teacher who has a summative score below 92 is rated ineffective. Between 92 and below 119 is rated minimally effective. Between 119 and below 146 is rated effective. Between 146 and below 173 is rated highly effective. And between 173 and 200 is rated exemplary. Additionally, the summative report provides the teacher with a bar graph of their score relative to their district and to the state. In this way, the teacher is able to gain context of how they're performing relative to their district and state. This is a theme that we carry throughout the report wherever possible. So again, you're looking at the overall front page of the summative report, and as you can see below the score, you have a space for the principal and the teacher's signature. In cases where the teacher refuses to sign their summative report, I've heard Matt Montano offer to bring your colleague into your office to witness you giving the summative report to your teacher. The second page of the report goes into detail regarding the value-added data that make up the student achievement score on the front page. As you can see, the value-added data consists of data from 2013-14, 14-15, and 15-16. Each year has two columns associated with it: the number of students that were included in the model and the value-added score achieved by that teacher with those students. There are rows that correspond to the course groups or subtests that make up the teacher's value-added score. So this teacher in 2014, 15, and 16 administered the SBA and PARC assessments in English Language Arts 11. In 2014, the teacher may have taught more than 100 students. However, only 100 students had the requisite data to be included in the value-added model. And this teacher earned 2.078, a value-added score of 2.078 standard deviations above average. In 2015, this teacher had 91 students with the requisite data to be included in the model and achieved a score of 1.729. In 2016, this teacher had 115 students with the requisite data and achieved a value-added score of 1.513 standard deviations above average. In total, over those 3 years, this teacher had 306 students with the requisite data to be included in the value-added models and achieved an overall value-added score for English Language Arts 11 of 1.7621, standard deviations above average. The teacher also administered EOC exams, and in 2014, the teacher administered an English Language Arts 3 reading test, which may have been in Spanish, to 91 students and achieved a value-added score of 1.295 with those students. They didn't administer that same assessment in 15 and 16, and so as you see, the 91 students carries across, and the total value add is the same. Also in 2014, the teacher had 22 students that took the high school English, which more than likely was the writing test, and achieved a value-added score of 0.417. Again, you can see that score repeated over here because it's summing across and creating a weighted average, which we'll talk about here in a second. In 2015 and 16, we were able to be a little bit clearer in how we are reporting the end of course exam data, and we were able to separate out the reading and writing. And if your teacher administered the Spanish language arts assessments, this would say SLA, SLA. So this teacher administered the English Language Arts Reading and Writing, and in 2015 to 36 students who had the requisite data to be included in the model and achieved a value-added score of 0.471 with those students. In 2016, with 46 students with the requisite data, achieved a value-added score of negative 0.535 with those students. There were 82 students overall with a value-added score of just below zero, negative 0.0933. The ELA writing end of course exam, the teacher administered to 39 students with the requisite data and slightly below zero with negative 0.062. And in 2016, 49 students with a value-added score of 0.191. Overall value added for English Language Arts Writing in 2015 and 16 is 0.0787. So the overall score that this teacher was able to achieve was a value-added score of 1.1299. And that's with 589 students who had the requisite data over those 3 years and across all those tests to be included as part of the value-added models. The way that we come up with this score is a weighted average. The weighted average is you make a quotient where you multiply the number of students divided by the number of students multiplied by the value-added score. So 100 times this value-added score plus 91 times this value-added score plus 115 times this value-added score plus 91 times this value-added score plus 22 times this value-added score plus 36 times this value-added score plus 46 times this value-added score plus 39 times this value-added score plus 49 times this value-added score. And so you take the sum of those products and you divide it by the total number of students that were in the model. So 589. And when you make that division, the result is 1.1299. So the overall value-added score is a weighted average of all of these value-added scores within those 3 years and across those tests. And this figure down here is to help you interpret the overall value-added scores as well as the scores within the table. Additionally, you are able to follow this link to gather more information. And if you right-click on this link, which I strongly suggest, and open it into a new browser, you won't get navigated away from that teacher's report. If you happen to left-click the link, it will take you away from that teacher's report. So right-click and open it in a new tab or browser. So the third page is a scatter plot. And the scatter plot shows on the vertical axis student growth. And on the horizontal axis, it shows the student's prior achievement. So in some sense, you have the two sides of the similar coin, growth and achievement. And if your students are above this horizontal line, then they're doing better than expected given in terms of growth, given their academic peer group. If they're on this side of the vertical line, the students are coming to the teacher with higher than average academic preparation. This side with lower than average academic preparation. So in this quadrant, you might say these are your high growth with lower prior achievement students. In this quadrant, you might say this is your high growth and higher achieving students. In this lower left quadrant, you have students who come to the teacher with lower than average academic preparation and are demonstrating growth less than what would have been expected given their academic peer group. In the right side of the scatter quadrant, you have students who have higher than average academic preparation and lower than what would have been expected growth given their academic peer groups. As you can see, there's a legend down here to help interpret the shapes and colors of the points in the scatter plot. So the blue squares are from 2014, the yellow circles are from 2015, and the red diamonds are from 2016. This scatter plot can convey quite a bit of information that an instructional leader can use to have critical conversations with the teacher, and the teacher can really use as a tool for reflection on their practices. For if you see, once you start looking at several scatter plots, you might begin to notice patterns. You may find that all the students are on the right side of the line and they're up here in this quadrant. And you might ask the teacher might ask themselves, what am I doing to really grow my high achieving students? Or if they're high achieving students or majority down here, what's going on that I'm not able to reach my students who come to me fairly well prepared? Similarly, you can ask the same questions about these students and these students. And as you begin to look more and more scatter plots, you will begin to recognize various patterns. Two limitations with the scatter plot as it currently is displayed is that we are unable to disentangle point collision. So if two students or more have exactly the same performance, growth, and achievement, they will collide, and especially if they're in the same year, you won't be able to distinguish them. The second limitation of the scatter plot is you can't disentangle what the course or subtest is of these points. Nevertheless, this is a valuable tool for the instructional leader and teacher to reflect on teacher performance. Next, you will find a series of bar graphs that display your teacher's score on domains 1 and 4 and domains 2 and 3. And as you can see, Alicia Duran scored 58 out of 60 points. Her school scored 45.76 out of 60 points on average. District 43.46 points on average. And the state 43.51 out of 60 possible points on average. In domains 2 and 3, Alicia scored 44.5 relative to her school, her district, and her state. In order to turn this into the points possible on the front page, you divide this score by 50, and that'll result in a proportion. You multiply that proportion by the total points possible, and that will give you the points on the front page, the summative points. So you just divide 58 divided by 60, it'll give you a proportion. You multiply that by the total points possible, and that gives you the score that the teacher earned on the front page of the summative. A question that you might want to ask yourself or ask your teacher is, are your classroom practices and behaviors and professional practices behaviors in and out of the classroom yielding high observation scores? And now that the student achievement data is of the same school year, you might ask yourself, to what extent can I learn from my profile of performance on my observation scores about how I might be impacting students? The next set of bar graphs depict the teacher's profile of performance across the 22 indicators on the NMTEACH rubric. So in domain 1, this teacher is scoring, 5 out of 5 on all 6 of the indicators. And the labels of the indicators are just below the bar graph. In domain 2, the teacher still has room to grow in 4 out of the 5 indicators. In domain 3, the teacher still has room to grow in 3 out of the 5 indicators. And in domain 4, the teacher has room to grow in 2 out of the 6 indicators. The bars also are associated with colors, where 1 point is associated with the color red, 2 points are depicted by this kind of orangish color, 3 points are represented by a yellow, 4 points by teal or turquoise, and 5 points by jade. So there's a legend to help you understand the coloring of the bars. So here's a note in terms of the observation data. If observation data were entered into Teachscape, or now Frontline Oasis, but the submit button was not clicked, your teachers will not have data for that observation event. If we don't have domains if we don't have data for domains 2 and 3, for your teacher, we will not produce a summative report for your teacher. In other words, it's the domains 2 and 3 data, the classroom observation data, that initiates the summative report. Attendance. So again, attendance here, the number of days absent reported from the district to the state for this teacher was 5.15 days. And this teacher's absences are relative to the school, district, and state. You might ask yourself, or the teacher might ask, or you might ask the teacher, to what extent is my attendance impacting my overall performance? And by now you probably are aware of the attendance grace period policy, where a teacher is able to earn 100% of their attendance points if they miss 1, 2, or 3 days of school. However, if they miss more than 3 days of school, then all of the days will be counted against their attendance points. So as you can see, that teacher had 100% or 10 out of 10 points out of attendance, but they still had 1 day absent. So if your teacher is missing more than 3 days, then all of their absences will be counted against their attendance points. So here we're going to talk about the value-added model in more detail, and we're going to use we're going to help describe the academic peer groups. And there's some animation. It's a little fun to watch Joseph move around on the page. So in 2010, Joseph scored 30 on his SBA, and in 2011, Joseph scored a 32. So he's moving. So Joseph's only going to be compared with students across the state in his grade levels that scored 30 on the SBA in 2010. And he's going to be compared against other students who scored 32 in 2011 on the SBA. In other words, Joseph's only going to be compared against students who have a similar score history on the tests. So Joseph's only going to be compared against students who have a similar score history or have the same prior achievement scores. Those are his academic peers. Students who have the same prior score history. And we'll see in a second on the next slide how we use regression analysis to arrive at the expected value. So in this case, the 2012 SBA is on the vertical axis. The 2010 and 11 SBAs are represented by the horizontal axis. And there's this diagonal regression line that runs through the middle of these points. It's really known as a conditional average. It's the average of the academic peer groups. So if this vertical line represents Joseph's academic peer group, the average of that academic peer group is right on the line. It's the average conditional on the prior achievement. So this triangle, this orangish triangle, is the expected value for this academic peer group. If Joseph scored here, or was this green olive, no, if this point, he would have outperformed his academic peer group by that much. However, if Joseph had scored here, he would have underperformed relative to his academic peer group. So Joseph's only being compared with his academic peer group, or students with a similar score history. So now let's take it to a real example using 5th grade math scores as predicted by 4th grade math scores. So here's an example that we call the tale of 3 teachers. It's real data, and you have the 2013 5th grade math scale score on the vertical axis, and you have the 2012 4th grade math scale score on the horizontal axis. This white dashed line is the population regression line, similar to the line on the previous slide. So let's for a moment erase the green line, the blue line, and the pink line. And if you were to subtract from every student's score the score that was predicted on the white line, so the difference between the score and the white line for every single student, you would arrive at what we call residual scores or deviation scores. If you were to take the average deviation score by each teacher, the teacher in green would have a positive deviation score because their students are performing better than average. If you summed up these purple scores, the average deviation score would be negative because these students are performing less than average given their academic peer groups. And if you summed up the blue points, they'd be right below average, just about 0, but just below, as this teacher's line is just below. The value-added score is actually the difference between each individual teacher's line and the population line. So this vertical distance between each individual teacher's line and this white dashed line is the value-added score. This is the score that you find in the cells on page 2. And the number of students are these points in the space. So let's just look. If you started out at about 35 and you had the green teacher, you're expected to score at about 42.5. Whereas if you got the blue teacher, you'd be scoring somewhere around 32.5 on average. And if you got the pink or purple teacher, you'd be scoring somewhere around 30 on average. This difference that the green teacher is able to achieve with very similar students, that's the definition of value added. That's the definition of value added, is the vertical distance between the teacher's line and the population line. That's that number that you see on page 2. This is a picture of the old summative report where you had SBA, discovery, or an interim assessment, or a college and career ready assessment. And in this case, the teacher didn't have discovery data. Domains 2 and 3, the classroom observation, the multiple measures. Remember, if we have attendance data and we have survey data, we will apply both of them, and each will be worth 5%. So here's an example where we're going to talk about how to take this value-added score and compute the overall points on the front of the page. Quickly though, it's interesting to note that this teacher seems to be doing much better with algebra relative to geometry. And again, we arrive at this 0.07 using that weighted average formula, where you have 14 times this value-added score, 18 times this value-added score, 12 times this value-added score, 18 times this value-added score, plus 16 times this value-added score. You sum up all those products and divide by 78, or the total number of students, and you'll arrive at this 0.07. So how do we convert this 0.07 into the points that you see on the front page? We use something called the cumulative density function, or CDF curve. Cumulative density function. The cumulative density function converts any value-added score into a percentile score. And as we say, the value-added score of 0, meaning that that teacher's line is right on top of the population line. That teacher's scoring at least as well as 50% of the other teachers with similar students across the state. So that's how we convert each value-added score into a percentile using the cumulative density function. A teacher whose value-added score is negative 0.6497 is in the bottom 5% of the distribution, and they're considered ineffective with respect to the student achievement portion. A teacher whose value-added score, on the other hand, is above 1.6497 is in the top 5%, or scoring at least as good as 95% or better than 95% of other teachers with similar students across the state. A teacher whose value-added score is between 0.65 and 1.65 is in between the 75th percentile and the 95th percentile. A teacher whose value-added score is between negative 0.65 and positive 0.65 is scoring effective, and they're between the 25th and about 75th percentile. And between negative 0.165 and negative 0.65, they're between the 5th and 25th percentile, or thereabouts, and considered minimally effective. So if we plotted this 0.07 on the CDF curve, we would see that the percentile is just above average, as 0.07 is just above 0, and their percentile is 0.5296. You can compute the cumulative density function, or the CDF, or the percentile for any of these value-added scores using Excel. Excel has a function built into it called norms, N-O-R-M-S, norms dist, D-I-S-T. If you just typed equals using the equal symbol, and then norms, N-O-R-M-S, dist, D-I-S-T, open parentheses, and then typed 0.07, close parentheses, and pressed enter, the result would be 0.5296. So you can use that function in Excel for any of these values, and it might be a fun exercise for you. Once again, we use the cumulative density curve to establish the percentile for any value-added score across the whole range. As many of you know, in the past, it was the district plan that determined the student achievement measures. Districts could choose, 1, 2, or 3 student achievement measures for their teachers. They could choose SBA, DIBELS, end of course exams, CCR, interim assessments, group level measures, such as school grade measures, content or grade level VAM. This increased the number of high-stake tests being used across the state. It made things fairly confusing as some teachers were linked to subjects that they were not even teaching. And some teachers were linked to students that they weren't teaching, i.e. the Q1 and Q3 portions of the school grade. Now, in some sense, this might make good sense to the district if they want to incentivize certain cross-curricular behavior or, create some sort of a milieu on campus where teachers seemingly working together. And in practice, it made the teacher evaluations confusing. Using the STEP system and only DIBELS, EDEL, SBA, PARC, and end of course exams, the summative evaluations are more uniform and, as you can probably tell, easier to understand. We're only linking teachers to students that they taught in the courses that they taught or subjects that they taught. And again, I would strongly urge you to look at the course assessment linkage document found on the NMTEACH website under the toolbox link and under the superintendent's header. It's a spreadsheet, a workbook that associates each course code with an assessment by grade level and subject area, including the end of course exams. So go download it and use it and look at it. It might help you answer some questions regarding the summatives. The value-added model for DIBELS, so for grades kindergarten through second grade, it's the end of year composite score that's on that vertical axis or is the outcome variable in the DIBELS value-added model. For kindergarten, it's the average of their beginning of year and middle of year composite score that is used as the prior achievement on the x-axis. It's those beginning and middle of years that create the academic peer group. For first grade, it's the average of the beginning and middle of year and end of year in kindergarten that is used as the prior achievement. And for second grade, it's the average of the beginning of year, middle of year, and end of year in first grade that is used as the prior achievement. And it's those prior achievements which help set the academic peer groups. So your students are only being compared against other students with a similar score history. For the end of course exams, we have end of course exams for your history teachers, your art teachers, and it's building in the career and technical ed departments for teachers, your music teachers, your PE teachers, your agriculture teachers, your health teachers, and some of your science teachers, economics, government. And we use end of course exams to compute the value added for the end of course exams for the student achievement portion of the summative reports. If there's no EOC data, then we don't have any end of course exam to use on the evaluations. I will note this, that suppose a student starts out in one district for 40 and 80 day and then transfers to another district for 120 and end of year. And suppose in the first district no end of course exam was administered, but in the second district the district administered end of course exams. And let's say that the student took that end of course exam. Then the teacher in the first district will receive some portion of that student's end of course exam for those first two snapshots. In some sense, it's a shared accountability model similar to that with graduation. Now, in order for the end of course exams, in order for the student achievement data to factor into the evaluation, there has to be 10 students or more. The value-added model for the end of course exams, of course the end of course score is the outcome score, and that's on your y-axis. But your prior achievement for 2014 end of course exams was the 2013 and 2012 SBA reading and math scores. So 4 scores used as prior achievement for the end of course exams. In 2015, the prior achievement was the 2014 and 2013 SBA reading and math scores. So again, 4 scores, 2 for reading and 2 for math as prior achievement. In 2016, the end of course exams have the 2015 PARC reading and math and the 2014 SBA reading and math scores as prior achievement. 4th grade end of course exams will have 3rd grade SBA and PARC scores in reading and math as prior achievement. So similar to 2014, they were just SBA, 2015 they were just SBA, and 2016 they were PARC. So we use the reading and math scores from the SBA and PARC as a proxy for prior academic preparation for the end of course exams. So while this issue has been fixed to the best of our knowledge, and we've went through quite a few checking it, I just want to make a note that in some cases we have found teachers who are administering within the same school year, they're administering 2 versions of the end of course exam. So maybe 2 or 3 or 4 students will receive this end of course exam, and 20 students or 10 students will receive this end of course exam. And that was creating a slight problem. While the value-added scores are not incorrect, the scores within the cells inside of the totals might have had a summing problem, but it should, to the best of our knowledge, have been corrected. So science teachers that administer the SBA, your 4th grade, 7th grade, and 11th grade, will have SBA data as part of their value-added scores on the evaluation. Science teachers that don't administer the SBA will have the end of course exam data on their evaluation if they administered it. And if the science teachers administered both the SBA and the EOCs, end of course exams, both of those tests will be used for value-added scores for those teachers. So the teacher will have both types of data on their evaluation. Similar to Alicia Duran, who administered end of course exams and the PARC SBA for ELA 11, she has both on her evaluation. So as you know, the 11th grade science test is somewhat general. It covers the nature of science, physical science, life science, earth science, and science and society. And there are several courses associated with the 11th grade science, which you can find on the course assessment linkage document. And only those 11th grade teachers will receive the value added score for the 11th grade assessment. In the past, we have used a cross-classified model to identify the impact of the 9th grade teacher and the 10th grade teacher on the 11th grade students' science performance. No longer are we using the cross-classified model, so the 11th grade teacher is the only teacher who will be associated with the student's performance in 11th grade science. We strongly urge you to administer the end of course exams for your 9th and 10th grade high school teachers in science. I also want to make note that we at the state we use the 4-digit state course code to link teachers, students, and assessments for the value-added model. Again, the assessments associated with each course code, 4-digit course code, are available on the NMTeach website under the toolbox link and under the superintendent's header. It is a Excel workbook that has several sheets in there, and on each sheet you can see the course codes associated with that test. You may know this, that the 4-digit course codes are the first 4 digits of the 8-digit district course code. So that concludes my portion of the presentation of the webinar, and I believe that Matt Montano was able to address your questions that you had. Though if you continue to have questions as you review and analyze the summative reports, please don't hesitate to reach out to your NMTeach liaison. And I hope that you have a great day. And again, I really appreciate your attendance, and I look forward to future collaboration and your partnership. Have a great day.